Welcome. For the next hour, we'll walk, slowly and clearly, through 19 of philosophy's most unsettling paradoxes. No jargon wall, no race to solve anything. Each chapter is about 4.5 minutes, just long enough to explain the puzzle in plain language, show where the tension lives, and leave you with a steady thought you can fall asleep to if you like. You'll hear about knowability that seems to imply omniscience, sentences you can't honestly say out loud, models of math that bend meaning, clever bets that reward the patient, and ethical knots where no one is harmed still doesn't feel right. By the end, you'll have a map of the places where logic, knowledge, chance, and value rub hard, and a few habits for staying level when they do. Ready? Chapter 1. Fitch's Knowability. Start with an optimistic slogan. For any truth whatsoever, it could, in principle, be known. That sounds harmless and even inspiring. If reality holds no deep secrets, then every fact is at least potentially within reach of a careful knower. The surprise is that a neat little proof turns this optimism into something extreme. If every truth could be known, it seems to follow that every truth is already known. The bridge from knowable to known is the disturbing step. Here's the path in slow motion. Imagine some ordinary true claim, call it P. Perhaps P is there are exactly 17 coins in this sealed box. Now consider a slightly more complicated claim, P and no one knows P. That compound can be true. After all, the box might be sealed and uninspected, so P is true and nobody knows it. If you hold the optimism, every truth could be known, then this compound should also be knowable. Someone in principle could come to know that P is true and nobody knows P. But the moment anyone actually knows that compound, it explodes. Knowing P and nobody knows P would make nobody knows P false. The knowledge defeats the very sentence that was supposedly knowable. To avoid contradiction, you must say there is no such case. There is no true proposition that is both true and unknown, and that means all truths are known, omniscience by slogan alone. It disturbs because the original optimism felt so modest. Knowable sounded like a soft promise about possibility, not a hard claim about the present state of minds. The trouble is that some truths won't sit still under knowledge. As soon as you know them, they stop being the sort of truths they were. It is raining and nobody knows it can be true at noon and false at 12:01, just because a single person looked out the window. People try to escape in different ways. Some say the optimism was too broad. What we meant was that every ordinary truth could be known, not tricky self-referential ones that talk about who knows what. Others sharpen could be known to mean could be known without making it false, which blocks the bad step, but also changes the original idea. Another route weakens the underlying logic. If you restrict how conditionals and knowledge interact, the proof fails to go through. And a classic response separates language levels. Talk about truth and knowledge from one step up, never letting the object language say nobody knows P about its own sentences. That way, the fuse never lights. A practical takeaway is gentler. Some claims are unstable under being known. An investigation can change the very thing it reports on. Measurements disturb quantum states, publicity alters markets, announcements move crowds. In those zones, every truth is knowable is too blunt. What you want are guardrails, which claims keep their shape under knowledge and which collapse when a light is shined on them. So the optimism survives in a trimmed form. There are vast classes of truths that really are approachable. There are also truths that mix facts about the world with facts about our minds in a way that makes knowledge self-defeating. When you hear sweeping promises about transparency or total discoverability, remember this small, sharp lesson. Some truths make themselves false as soon as you claim them aloud. Chapter 2. Moore's Paradox. Say this out loud, sincerely. It's raining, and I don't believe it. Nothing in the grammar is broken. If you're under a blue sky, it's just false. If you're under a drizzle, each part could be true. Maybe you're oddly skeptical today. Yet you cannot, without absurdity, assert that sentence while meaning it. The clash isn't in the weather, it's inside the act of speaking. It disturbs because assertion is normally a window into belief. When you say it's raining, you aren't just moving air. You are presenting yourself as believing that content. The second half, and I don't believe it, yanks the rug. You put a belief on the table while reporting you don't have it. Nothing in logic forbids a state of the world in which it rains and you don't believe it. What's forbidden is the posture of telling me both at once while being rational. This shows the difference between contradiction in content and contradiction in use. It's raining and it's not raining contradicts itself even when printed silently on a wall. Moore's sentence becomes impossible only when voiced from the first person as a sincere assertion. A diary could record, "It's raining and oddly I do not believe it," as the remark of a psychologist studying a subject. You could sensibly say, "It's raining and yesterday I didn't believe it," because the belief report now has a different time. The paradox appears only when the mouth and the mind are supposed to line up here and now. The lesson runs deep. We rely on a kind of transparency about our own minds. If I can ask myself P and answer yes, then I both believe P and can say P. Moore's sentence pushes against that. It asks you to occupy two stances at once. The first-person voice carries a built-in promise of self-knowledge and minimal coherence. Breaking that promise doesn't produce a logical explosion. It produces the social and rational equivalent of a misfire. This matters for trust. When someone asserts P, you don't only learn about rain, you learn who they are as a knower. If their lips can deliver P while their mind disowns P, you lose the calibration that makes testimony work. And in our own heads, the paradox is a check on compartmentalization. If you catch yourself tempted to say, "He's a good friend," and I don't believe he is, you're not describing a subtle truth. You're flagging a fracture to resolve. The odd beauty is that the sentence can be true when someone else says it about you. "It's raining and Alex doesn't believe it" could be accurate and properly asserted. The problem isn't the weather report. It's the clash between the first-person commitment to a claim and the self-report of lacking that commitment. Philosophy rarely gives us a cleaner mirror of how belief, assertion, and self-knowledge interlock. So the next time a thought like this comes to mind, let it do its quiet work. Good assertion isn't just about accuracy. It's about alignment between the world, your belief, and your voice. Where that alignment snaps, nonsense doesn't erupt, but credibility does. Chapter 3, Curry's Paradox. Imagine a sentence that says, "If this very sentence is true, then Santa exists." There is no not in sight, no denial. It simply ties its own truth to Santa's existence. Strangely, ordinary-looking rules can turn that pair into a proof of Santa. No sleigh required. That is Curry's paradox, and it shows how dangerous self-reference becomes when you mix it with a generous notion of if, then, and a truth predicate that stamps sentences as true whenever they match reality. The pressure builds in steps. If the sentence is true, then the conditional it states is true. And if that conditional is true, then by the natural rule that lets us apply a true conditional to its own premise, we get Santa. But the premise of that conditional is the sentence's truth, which is exactly what we started with. The circle has no negations and still squeezes out any conclusion you care to build into the tail end. Replace Santa exists with 2 + 2 = 5, and the same machinery proves that too. Keep these rules unrestricted and everything collapses. It disturbs because the rules look so innocent. We want the conditional to behave. If A then B is true and A is true, then B should follow. We want a truth predicate to behave. A sentence is true if and only if what it says is the case. And we don't want to ban self-reference outright. Sometimes we need to talk about our own claims, policies, or code. Curry shows that the trio, self-reference, a full-strength conditional, and an unrestricted truth predicate doesn't play nicely together. The responses all involve sacrifice. One path weakens logic, trimming rules that let conditionals combine freely. This is the world of relevant logics and systems that deny certain contraction steps. Another path weakens truth. You don't allow a global, one-size-fits-all truth predicate inside the very language it speaks about. You climb to a meta-language to stamp truth from above, or you build partial truth that declines to settle some sentences. A third path restricts which self-referential forms are well-formed at all. You can't say, "This is true" in the naked way the paradox wants. If that feels abstract, look at a policy portal. Suppose your organization runs a rule. Approve any request that, if approved, would be appropriate. Now write a request. If this request is approved, then all future requests must be approved. Feeding it through the portal threatens to infect the system with unconditional approval. The philosophy lesson is the same. Certain self-referential conditionals plus a general approval rule make everything pass. The quiet moral is caution where language turns inward. A well-behaved conditional is fine, a well-behaved truth notion is fine, and modest self-reference is fine, but not all three at once, without guardrails. Curry isn't a curiosity. It is a design warning for any system that endorses rules about rules, permissions about permissions, or truths about truth. If you don't plan the boundaries, the system will quietly prove whatever the worst request asks of it. Chapter 4, Yablo's Paradox. Picture an infinite list of sentences, numbered 1, 2, 3, and on. Sentence 1 says, all later sentences are false. Sentence 2 says, all later sentences are false. Sentence 3 says the same about those after it, and so on forever. No sentence points at itself. None says I am false. Each looks outward to the tail of the list. That should have avoided the usual self-referential trap. It didn't. Try to find a place to stand. Suppose some sentence in the list is true. Pick the earliest true one. If sentence n is true, then every sentence after n is false. But then sentence n plus 1 is false, which means all later sentences are false is itself false. So at least one later sentence is true. That contradicts the claim that all later ones are false. The earliest truth can't exist. Now suppose all sentences are false. If sentence 1 is false, then it is not the case that all later sentences are false, so at least one later sentence is true. But that contradicts the assumption that all are false. Every route loops back into trouble. It disturbs because many people thought self-reference was the villain in paradoxes like the liar. Ban sentences that speak about themselves, and you should be safe. Yablo shows that circularity can be ungrounded. You can defer reference step by step into the future, and still end up with no consistent assignment of truth values. The circle is there, but it's a circle of dependence across an infinite sequence, not a single sentence biting its tail. This matters for how we try to tidy up languages. Some approaches say you may not form a sentence that says of itself that it's false, and they hope the rest of discourse is healthy. Yablo's construction respects that rule and still breaks the system. The fix, if you want one, has to be deeper. You need restrictions that pay attention to chains of dependence, not just single forbidden forms. Or you weaken the logic so that not every instance of classical reasoning goes through. Or you adopt a groundedness view of truth. A sentence is true only if there is a bottom to the chain of what makes it true, something that doesn't itself depend on truth talk. There is also a softer reading. Sometimes a structure of beliefs or announcements can be incoherent, without any one claim being self-refuting. A whole crowd can arrange itself so that everyone looks to the next person for confirmation that never arrives. The lesson isn't never refer to yourself, but watch for patterns where every support leans on the next support and nothing touches ground. So the next time a fix promises safety by banning only the most obvious kind of loop, remember this infinite staircase. Going up step by step can land you in the same dizzy place as jumping in a circle. If your system can generate an endless line of everything after me is wrong, it owes you a better reason why that line won't saw itself in half. Chapter 5, Skoelm's Paradox. Set theory tells us there are more real numbers than whole numbers. No matter how you try to list the reals, some are always left out. They are uncountable. Another part of logic says that if a first-order theory like set theory has any infinite model at all, then it also has a model whose domain is countable. Put those side by side and you get the unsettling headline. There is a countable universe of sets in which there are uncountably many reals is perfectly true. It disturbs because uncountable sounds absolute. If I can list the things one by one, they're countable. If not, they're not. How could a world with only countably many objects contain an uncountable set? The key is perspective. Uncountable inside a model means there is no bijection from the naturals to this set that exists in the model. From the outside, a logician can map every element of the model, every set it contains, onto the natural numbers. But that mapping lives in our meta-theory, not inside the model. The inhabitants have no function that pairs their naturals with their reals one-to-one. We, looking from above, do. This shift reveals how first-order descriptions leave wiggle room. The theory can say there exists no function f such that f is a bijection from n to r, and that can be true within a countable model because the model simply lacks any object with the right pairing property. Our external pairing isn't one of their objects. Meaning slides with the inventory of functions and sets a model contains. The result isn't a contradiction, it's a calibration. First-order set theory can't pin down size uniquely across all models. If you want only models where uncountable matches an absolute notion, you need stronger tools, second-order logic with full semantics, or extra axioms that concentrate the possibilities. Even then, other surprises await. The moral isn't that mathematics is arbitrary, it's that mathematics conducted in a given language sees only what that language can express about the objects it has. There's a helpful way to live with this. When a community uses countable, it is always implicitly countable by us, using the functions we can define and the processes we accept. Skoelm makes that implicit clause visible. In some models, the people inside can't find a listing for the reals, so they are uncountable for them. We, with a higher vantage point, can list their entire world, but our list isn't a tool they possess. What this teaches outside of set theory is humility about perspective. Claims that seem absolute may be absolute relative to what the system can say and show. When debates about meaning, measurement, or possibility grind, ask which model each side is living in, what objects, functions, and inferential tools are actually on their shelves. Often the paradox softens when you see that two viewpoints can disagree without either being inconsistent, simply because they quantify over different inventories. So Skoelm's paradox isn't a glitch in arithmetic, it's a reminder about the gap between a theory and its models, between a word like uncountable and the structures that make that word true. Once you see that gap, the confusion drains away, and you're left with a deeper respect for how much work a language quietly does in shaping the world it can describe. Chapter 6, Berry's Paradox. Try to point to a number using only English. 1, 1,000, the first prime after 10 million. We can describe many numbers with short phrases. Now say this slowly, the smallest number not definable in under 13 words. If that phrase succeeds, it points to a specific number, but count the words. It just defined that number in under 13 words. The target disappears the instant you aim at it. What's happening is a tangle between language and what language can create. We treat definable in under 13 words like a clear property. For most phrases, it is. The least common multiple of 8 and 10 fits. But when a phrase talks about phrases of a certain length, especially about not being definable within that length, it starts to bend back on itself. The problem is that English is sloppy. Even very strict formal languages can reproduce the trick once they have enough power to talk about their own descriptions. One natural fix is to raise the bar and ban the move. You might say, only definitions that use mathematical terms count, not meta-talk about definitions. But then you can write the smallest natural number that cannot be uniquely picked out by any formula shorter than this one, and the loop returns. Another idea is to restrict what counts as a definition. Mathematicians sometimes turn to the cousin of this paradox called Kolmogorov complexity. Think of a definition as a computer program that prints a number. The length of a definition becomes the number of symbols in the shortest program that outputs that number. In this setting, you can prove that there must be numbers with no short programs. So the broad idea, some numbers are not definable in a few words, is right. But here's the twist. There is no algorithm that can take an arbitrary number and always tell you its exact complexity. You get a rigorous boundary and with it, an inbuilt limit to what you can certify. So Berry's paradox doesn't show that mathematics is broken. It shows that mixing counting of descriptions with the power to describe those counts leads to traps. When you try to name the smallest number you can't name quickly, you create a race you win by losing. The practical lesson is to keep levels apart. Talk about numbers on one level and about talking about numbers on the next. Or accept that some questions about definability are not the kind you can settle by calculation. You may never need this in daily life, but it's a good mental guardrail. Anytime you're tempted to define a thing in terms of whatever cannot be defined under Rule R, pause. You might be building a sentence that erases its own subject. Some ideas close the door behind them the moment they enter the room. Chapter 7, Goodman's Grue and the Wobble in Induction. We've seen thousands of emeralds, and every one has been green. That seems like sturdy evidence that the next emerald will be green too. Now meet a made-up word, grue. An object is grue if it is green before a fixed future date, say for January 2050, and blue after that date. Every emerald we've checked so far has been grue as well as green because we looked before 2050. So the same evidence seems to support two rival predictions. Future emeralds will be green, and future emeralds will be blue. Something has gone wrong. The point isn't that emeralds will actually turn blue, it's that past harvests can be packaged under different concepts, and some packages lead us to silly forecasts while others lead us to sensible ones. We feel that green is projectable into the future while grue is not, but we owe ourselves a reason beyond it sounds dumb. One answer says that green tracks a natural property of the world while grue bakes in a calendar trick. Another says the problem is our language. You can make a vocabulary where grue looks simple and green looks gerrymandered, and then the tables turn. A third answer turns to entrenchment. Terms we have successfully used in many inferences, like green, earn the right to be projected again. Grue has no track record. Modern confirmation theory often handles this by combining prior plausibility with simplicity costs. The grue hypothesis is more complex because it needs a cutoff date and a two-part rule. Green forever is cheaper to state and fits more worlds without special features. On a Bayesian view, evidence multiplies with priors. When you penalize gerrymandered predicates up front, the ordinary green hypothesis wins the tug of war. There's also a down-to-earth moral. We constantly choose the features we think matter. In medicine is the crucial pattern fever followed by rash, or fever before 2025, rash after. In economics is the right variable inflation rate, or inflation until election then rate. You laugh, but political cycles make silly predicates look relevant. The grue lesson is to keep your predicates honest. Pick features that line up with mechanisms, not with arbitrary dates or convenient hindsight. So yes, past green emeralds still confirm future green emeralds, but they do so because we aren't just counting. We're also judging which descriptions carve the world at joints and which ones are stitched together to win a bet. In that judgment, simplicity, mechanism, and past success all have a role. When someone shows you a fancy relabeling that makes noise look like signal, remember grue. You can make any history look predictive if you smuggle the prediction into the words. Chapter 8. Old Evidence and New Theories. Sometimes a new theory explains a fact we already knew. Einstein's general relativity accounted for Mercury's strange perihelion advance, a wobble in its orbit that Newtonian gravity couldn't handle cleanly. After 1915, that old measurement suddenly felt like powerful support for the new theory. But if the evidence was already on the books, in what sense did it confirm anything? In a standard probability model, updating on evidence you already assign probability 1 does nothing. The worry is largely about bookkeeping. Old evidence becomes confirming when a theory turns a puzzling datum into an expected one. Before the theory, the fact did not sit in your web of beliefs with a clean explanation. It was a tolerated annoyance, a fudge factor, an exception patched with epicycles. After the theory, the same fact is now predicted with no ad hoc fixes. If you model this properly, you don't treat the bare measurement as the only thing to update on. You also treat "this theory explains E without special pleading" as fresh information. That proposition can have a probability less than 1 before the theory arrives and substantially higher after, so it can raise your credence. Another fix is to be honest about certainty. Outside of pure math, you rarely have genuine probability 1 about empirical facts. You can assign 0.999 to the Mercury anomaly before 1915 and watch your credence in relativity jump when you combine that near-certain fact with a clean derivation. A third line of thought takes confirmation to be comparative. What matters is not whether E raises the probability of T from 0.33 to 0.34 in a vacuum, but whether T now beats its rivals on E without penalty. Rival theories that needed weird patches to fit Mercury lose points. Elegance plus accuracy wins points. This connects to how science really works. Theories don't just predict, they organize. They compress many facts into a short description that lets you recover them from a common principle. Old evidence can suddenly carry new weight because it now belongs to a tight pattern rather than a pile of exceptions. In machine learning, you can hear the echo. A model that explains data with fewer parameters earns trust, even if the data are old. The everyday lesson is gentle. You already have old evidence about your life, patterns in a friend's behavior, in your own habits, in a market you watch. When a new story makes those scattered facts click together without special pleading, you're right to treat the old evidence as fresh confirmation. The trick is to penalize stories that win only by adding knobs and dials for each awkward datum. A good theory lowers the number of knobs and still fits the curve. So the paradox softens. Old evidence can confirm new theories, not by time travel, but because confirmation is about fit, competition, and economy of explanation, not just a mechanical probability updated on a single already known sentence. Chapter 9. The Raven's Puzzle and the White Shoe. All ravens are black. That sentence is equivalent to all non-black things are non-ravens. Logic says they stand or fall together. If you accept a simple rule, any observed thing that fits a universal generalization confirms it, then seeing a black raven confirms all ravens are black, and seeing a white shoe, which is a non-black non-raven, does too. That feels silly. Shoes shouldn't help with ornithology. The tension isn't that logic is wrong, it's that relevance matters. When you observe a black raven, you sample from the very class named in the claim. When you observe a white shoe, you sample from a vast class of objects that almost never bear on raven color. Under a careful probabilistic model, both observations can raise the probability of the universal statement, but the black raven raises it by a lot, while the white shoe raises it by a whisper so small you can ignore it in practice. Background knowledge also matters. If you already know that most of the world's objects aren't ravens, then learning that yet another non-black thing is not a raven teaches you almost nothing. The space of non-black objects is huge. Paper, snow, salt, clouds, concrete. Each additional non-black non-raven barely moves the needle. By contrast, seeing more ravens, especially in places and times you haven't sampled, directly tests the regularity you care about. There's a second practical filter: sampling process. A white shoe seen in a closet you chose because you were cleaning doesn't resemble a random draw from the universe. A black raven seen during a dedicated survey that tries to be representative tells you much more. The paradox plays with a rule abstracted from messy practice. Once you put the practice back in, what you knew already, how you gathered data, where you looked, the intuition aligns with the math. A nice payoff is a better habit of mind. When someone waves around lots of confirming instances that come from outside the target class, ask whether those observations were likely anyway given your background. This stock went up on a day with cloud cover tells you nothing about finance. This new sample of ravens in a new region is also black. Does help. Confirmation depends on how surprising the observation would have been if the hypothesis were false, and if your background is true. So the white Jew can confirm the raven claim in a strict, thin sense. It just confirms it so faintly that only a logician with a microscope would care. That's a feature, not a bug. The logic enforces consistency across equivalent statements. Our judgment enforces relevance by weighting the right kinds of observations. Keep both in play, and the shoe goes back to being a shoe. Chapter 10. The Lottery Tension. Belief versus confidence. Imagine a fair lottery with 1 million tickets and one winner. For any single ticket, it's perfectly reasonable to think, this ticket will lose. The odds are overwhelming. If you form that belief about each ticket in turn, you would end up believing of every ticket that it will lose. Taken together, that says no ticket will win, which you know is false. You haven't violated arithmetic. You've run into a fault line between all or nothing belief and graded confidence. One way out is to stop using flat beliefs in such cases and use credences, numbers between 0 and 1 that record how confident you are. You can have 0.99999 confidence that ticket 137438 will lose without ever asserting flatly that it will. Probabilities add and interact cleanly. Categorical beliefs can collide when you combine many of them. Another route is to keep flat beliefs but adjust the rules. You only accept a claim if it crosses a high threshold and remains safe under relevant combinations. That is, don't allow yourself to accept each this ticket will lose if the set of acceptances would jointly commit you to something you know is impossible. There's a deeper moral about closure. Philosophers often assume that if you rationally believe P and you rationally believe Q, you should rationally believe P and Q. The lottery shows that this closure rule can be too strong in uncertain environments. It's sometimes better to let belief be contextual and limited. You can act on "this ticket will lose" when deciding not to spend extra money on it. Yet you should refrain from aggregating that stance across all tickets to draw the impossible conclusion that no one will win. Daily life is full of lottery structures. You think each email is probably unimportant, but you shouldn't conclude that all the day's emails are unimportant and ignore them. You judge each bridge inspection unlikely to fail, but you don't conclude all inspections are safe and skip redundancy. The fix isn't to become timid. It's to recognize that policy-level conclusions often demand different standards than item-level conclusions. There's also a communication angle. When experts say a side effect is unlikely, they are speaking in credences. Listeners often translate that into flat belief, it won't happen, and then feel betrayed when it does. The lottery reminds us that highly reasonable single-ticket bets can be collectively guaranteed to disappoint someone. Honesty about risk means talking in percentages and ranges, not in absolutes, and being explicit about what happens when many small risks stack. So, don't throw out belief and don't worship probability. Use each where it fits. Believe outright when the stakes and context justify it. Keep numbers when aggregation and policy loom. The paradox is just a warning that our yes-no minds live in a maybe world, and careful thinking needs both gears. Chapter 11. Tension. Believing it all, admitting you missed something. Picture an honest author finishing a book of careful claims, hundreds of them, each checked against sources and colleagues. On the last night, they write a standard preface line. "Despite my best efforts, there are surely mistakes within." That sentence sounds admirable, even required. But now line up the attitudes. For every chapter claim inside, the author believes it. And also, the author believes that at least one claim in the whole book is wrong. Put those together and it looks like holding P1 and P2 and Pn, while also holding not P1 and P2 and Pn. Isn't that a clash? It feels troubling because we think rational belief should close neatly under conjunction. If you reasonably believe each claim, shouldn't you reasonably believe the conjunction of all of them? Yet anyone who's lived around research, audits, or engineering knows the preface stance is exactly what good thinkers adopt. Confidence in each part, humility about the whole. A calm way through keeps two distinctions in view. First, belief isn't a single switch. It's a calibrated stance that tracks risk. When you check one statement, you set a high credence, say 0.97, and move on. Do that for 500 statements, and the expected number of errors isn't zero. Even if each is very likely true, the chance that all of them are true at once can be low. So the author's pair of attitudes can be coherent. Believe each item strongly enough to print it. Also believe a modest, statistical claim that somewhere in the pile there's a miss. The clash dissolves once we stop pretending believe always means probability 1. Second, believe and accept for the current purpose come apart. In science, law, and policy, we often accept many premises to run an argument, sign a contract, or publish a result, while keeping a meta-level recognition that the package as a package is fallible. Acceptance is a practical stance, good enough to act on, without the fiction of absolute certainty. The preface admits fallibility without pulling the book from the shelf. There are still lessons to draw. One is about closure. Some attractive rules, if you rationally believe each, rationally believe the conjunction, don't survive contact with uncertainty. A better rule says you may believe each for its local role while withholding belief in the global conjunction if you also have ample reason to expect small independent errors somewhere. Another is about honesty signals. Prefaces like this don't reduce trust, they earn it. They tell readers the author understands how error rates scale and has not mistaken care for infallibility. Daily life is full of preface moments. You trust each step in your tax filing, yet admit you might have mistyped a number. You check each door lock and still allow that one might be unlocked. You believe each forecast from a model you calibrated, and you track an overall error bar. The rational posture is not to abandon particular beliefs, but to pair them with modest aggregation. Treat the whole set with a bit more caution than any component. If a puzzle remains, it's the feeling that you're contradicting yourself. You're not. At least one claim is wrong, doesn't name which one, and it doesn't defeat any particular claim. It's a statistical umbrella, not a sniper. The umbrella and the list can coexist without fracture, as long as you resist the habit of forcing everyday belief into all or nothing logic. Good thinking needs both gears: commitment in the small, humility in the large. So, keep the preface. It's not a confession of sloppiness, it's a calibration mark. Believe what you've earned the right to believe, and keep a steady hand on the idea that large projects almost never land with zero dust. Chapter 12. Real barn, fake county. When knowledge trips on luck, you're driving through a rural county you don't know. Out the window, rustic scenes, red fronts, sun-baked roofs. You glance right and say, "There's a barn." You're right, this one is a real barn. Later, you learn an odd local fact. The county is full of movie facades, convincing front boards that look like barns from the road. Only 1 in 20 is genuine. Suddenly, your earlier "I knew that was a barn" feels shakier. The object was a barn, your eyesight was fine, but was it knowledge or a lucky hit? The case feels unfair because nothing about your vision or honesty changed, only your background context. Yet that context matters for what we call knowing. Think of knowledge as not just truth plus justification, but also robustness. A belief is robust when it would still be right across nearby possibilities, if the world shifted a little, or if you had looked a second earlier, or if the angle was slightly different. In fake barn county, most nearby cases would have fooled you. Your method, look from a car for a second, easily lands on fakes. That fragility is why many say the belief was true but not knowledge. Philosophers capture the idea with safety and sensitivity tests. A belief is safe if, in close situations, you wouldn't easily have believed the same thing falsely. It is sensitive if, had the claim been false, you wouldn't have believed it. In the barn county, your "that's a barn" belief is unsafe. In many close-by worlds, same road, next facade, you'd have said the same words and been wrong. We care because knowledge is supposed to guide action reliably. A method that wins mostly by luck shouldn't get promoted to knowing, even when it lands on truth once. This isn't an argument for paranoia, it's a reminder to calibrate to base rates. When the environment is flooded with convincing fakes, scam emails, deep-faked videos, lookalike websites, the very same glance or click that worked in a safer environment no longer produces knowledge. You might still get truths, but you won't have earned them in a way that travels. The fix is to enrich the method. Slow down, seek second cues, add a verification step that would break on the fakes, walk up to the building, check for a back, read the zoning record. There's a hopeful flip side. If you change the method, knowledge returns. A contractor who taps the beams, checks the foundation, and reads the land registry can know it's a barn even in a county lousy with facades. The environment didn't improve, the procedure did. Knowledge isn't snobbery about lucky people. It's a label for beliefs formed by processes that stay right when the wind shifts slightly. In the digital world, fake barn counties multiply. Social feeds place glossy fronts beside genuine reporting. A quick glance that once counted as "I know" needs a filter. Source, reputation, verse image search, time delay, corroboration. The standard isn't perfection. It's that small changes, different link, different crop, different timestamp, wouldn't flip you from true to false routinely. So keep saying "barn" when you see one, but keep an eye on the neighborhood. When fakes are rare, your trust in perception is enough. When fakes are common, update the method before you upgrade the belief to knowledge. Truth plus luck isn't what we mean by knowing. Truth plus resilient method is. Chapter 13. Sleeping Beauty and the Weight of Waking Up. Here's the setup. On Sunday, you agree to an experiment. A fair coin will be tossed. If it lands heads, you will be woken on Monday, interviewed, and then the study ends. If it lands tails, you will be woken on Monday, interviewed, put back to sleep with a memory wipe of the awakening, and woken again on Tuesday for the same interview. When you awaken for an interview, you don't know which day it is. The question you're asked each time: what is your credence that the coin landed heads? 2 answers have loyal defenders. Halfers say 1/2, The coin is fair, you knew the protocol in advance, and awakening gives you no new information you didn't already expect. You were guaranteed to wake at least once either way. Thirders say one-thirth. In the long run, for every heads run, there is one awakening. For every tails run, there are two awakenings. If you sample uniformly from awakenings, 1 out of 3 will be heads awakenings. On waking, you should treat yourself like random awakening, hence one-thirth. It helps to slow down what new information you actually get. You learn you are awake now. Under heads, there is one such awakening. Under tails, there are two. That asymmetry is information, even if you always expected to wake at least once. If you were guaranteed 1 awakening under heads and 10 under tails, waking would strongly push you toward tails. The 2 awakening version is just a milder case. On this reading, the thirder answer captures the self-location update. Given that you are one of the actual awakenings, tails is more represented in that pool. But a halfer can reply that you shouldn't sample over awakenings, you should sample over coin tosses. Before sleeping, you plan to keep credence half in heads whenever you wake, because waking was never evidence against heads, it was scheduled no matter what. They'll also warn that some betting setups make thirders vulnerable to double counting losses across the 2 tails days. Thirders answer with bets that pay per experiment rather than per awakening, aligning stakes with the structure you endorse. What this really reveals is that probabilities about the world and probabilities about your location within the world can pull apart. When your evidence says you are this kind of observer moment, it can shift odds even when the external setup hasn't changed. In dexical information, facts about where and when you are has force. We don't notice it in ordinary life because duplication and memory erasure aren't common features of Mondays. There's a practical lesson in the background noise of big systems. Be precise about the unit you're sampling. Are you reasoning over events, over people, or over observations? In medicine, do you count hospitalizations or patient days? In web metrics, users or sessions? Mix them, and your updates will sway for hidden reasons. You can sleep well without picking a side. The experiment displays 2 clean logics keyed to 2 clean reference classes. If your decisions are paid per awakening, thirder odds guide fair bets. If they're paid per experiment, halfer odds can. The remaining friction isn't about arithmetic, it's about what, exactly, your moment of awareness should condition on. Chapter 14, the Doomsday Update, reading humanity from your ticket number. Stand in line at a bakery holding ticket 47. Without looking around, can you estimate how many people will be served today? You might guess that you're somewhere typical in the queue, not the very first and not the very last. Transfer that intuition to human history. Your birth rank among all humans who will ever live might be used to estimate how many there will be in total. That move, when made more formal, is the Doomsday argument. The skeleton is simple. Suppose you treat your birth number as a random sample from all human births, past and future. If you're number 117 billion, rough ballpark, then worlds in which trillions upon trillions more people will live put you unusually early in the sequence, which they make less likely. Worlds in which humanity ends relatively soon put you closer to the middle, which they make more likely. When you combine this typicality prior with your existing beliefs, the posterior nudges toward shorter futures. The argument doesn't say doom is tomorrow. It says that, all else equal, incredibly long human futures become less plausible given your random-seeming position. It hits a nerve because it feels like numerology with a trench coat. Why think you're a random draw from all humans who will ever live? What's the reference class? Humans, observers, observers who can formulate the argument. If you expand or shrink that class, the update shifts. And what about ordinary priors about technology, colonization, and survival improvements? If you already think risk can be managed, a light typicality nudge may not move you much. There are reasonable replies on both sides. Defenders say the argument is just a modest Bayesian update. Learning you're near the median of a sequence is data, just like your bakery ticket. Critics say the sampling assumption is wrong. You are more likely to exist in worlds with many observers, the self-indication idea, which counteracts the doomsday push. Others focus on model error. Human population is lumpy, booms and busts, pandemics and progress, so a smooth, typical picture misleads. The good that comes from wrestling with it is a sharper eye for anthropic reasoning. Cases where your own existence or your standpoint within a process is part of the evidence. Cosmology, AI forecasting, and risk analysis all have versions of this puzzle. You don't need to swear allegiance to any one fix. You can keep the reminder that survival curves shouldn't be painted with wishful thinking, and also keep the caution that clever conditionals about observers like me can hide assumptions about who counts. As a guide for action, the argument is less about despair than about urgency. If long futures are not automatically favored by the math, then securing them takes work. Reducing tail risks, building institutions that can survive pressure, and spreading resilience across many failure modes. Your ticket number doesn't doom you. It just urges you to treat longevity as a prize that needs winning, not a baseline that arrives by default. Chapter 15. Boltzmann brains and the worry about typical minds. Imagine a universe that lasts for inconceivable stretches of time with particles flickering and entropy drifting upward. In such a sea, rare thermal fluctuations can very occasionally assemble a momentary brain with random memories, a fleeting now, and then rapid dissolution. If the cosmos is vast enough and old enough, those Boltzmann brains might outnumber brains like yours that grew inside stable bodies on planets around stars. If typical observers are the ones we should bet on being, the conclusion would be bleak. You should expect to be a fluctuation with fake memories, and ordinary evidence loses its grip. This feels like science fiction until you notice why it bites. Many theories in cosmology imply huge volumes and long durations. If the math lets fluctuating minds proliferate without limit, then your confident sense of being a product of history becomes statistical wishful thinking. And if you grant the typicality idea that you should treat yourself as randomly drawn from a pool of observers, the pool choice matters. If the pool is flooded with brief, confused flickers, the method tells you that you're probably one of them. Trust collapses from the top down. There are several ways to step back from the cliff. The first is empirical. Prefer cosmologies that suppress Boltzmann brains. If the universe decays, or if its expansion dynamics prevent the right kind of thermal fluctuations, or if quantum rules make complex fluctuations astronomically rarer than once thought, then ordinary observers reclaim the statistical majority. This isn't special pleading. It's a selection principle used by cosmologists when comparing models. Theories that imply self-undermining typicality, most observers are deluded, are treated as defective on methodological grounds. A second move questions the typicality rule itself. Perhaps you shouldn't treat any conscious moment as an equal candidate. You might weight by causal history. Minds produced by stable processes get more measure than freak fluctuations, or by duration and complexity. Those proposals are controversial, but they show the lever points, change what counts as the reference class, and the conclusion changes. A third move is conceptual. Even if a universe produces many Boltzmann brains, a policy of trusting ordinary evidence may still be the best available. If you are a fluctuation, no policy saves you. Your perceptions are off by design. If you are an evolved observer, policies that ignore your evidence hobble you for no gain. So the practical recommendation to trust structured memories and ongoing experience can survive the skeptical story, much like you ignore the tiny chance that you are dreaming when driving to work. Underneath the puzzle is a reminder about self-undermining theories. If a view predicts that most believers in it are in no position to form true beliefs, that's a reason to lower your confidence in the view. Boltzmann brain-dominated cosmologies do precisely that. They tell you to distrust what made you believe them. Scientific practice has a nose for such loops and prefers models that leave most observers epistemically upright, so you can let the worry do its quiet good work. It guards against sloppy appeals to bigger is better when comparing cosmic stories, and it refines how we think about being a mind among minds. Your experiences come knit together by reliable causes across time. That coherence is not just comforting, it is a piece of hard evidence about which kind of universe you're likely to inhabit. Chapter 16, Living Under Glass, Credence in the Simulation Idea. Start from a sober thought, not sci-fi. If future civilizations can run cheap, vivid simulations of minds like ours, and if they enjoy doing that at scale, then simulated observers would vastly outnumber biological ones. If you treat yourself as a fairly random observer drawn from that big pool, the chance that you're simulated rises. It disturbs because the conclusion seems to undercut the very evidence you use to reach it. If your memories were typed in by a cosmic game engine 5 minutes ago, why trust telescopes, thermometers, or history books? The first stabilizer is to pull the idea apart into 3 claims. Either civilizations like ours die before they can run such simulations, or they get there but choose not to, or they do it and fill the cosmos with them. If you think the first 2 are plausible, your credence in "we are simulated" can stay modest without hand-waving. And even if your credence is not tiny, guidance for living does not evaporate. The key is to ask what policies would make sense across both possibilities, base, reality, and simulation. A practical answer is to treat ordinary evidence as your default compass. If you are in base reality, ignoring your instruments is folly. If you are in a simulation, your instruments are still the rules of the game you actually inhabit. The only time you should diverge is if you have reason to think the simulators reward certain behaviors, benevolence, curiosity, restraint, or punish others. But here humility is your friend. Tall claims about what impresses hypothetical designers are cheap. Sticking to ordinary ethics, don't harm, keep your word, learn, help, does double duty. It serves creatures like you whether they're carbon or code. It also matters that "we're in a sim" is not a single story. Some versions are epistemically kind, stable physics, consistent histories, no meddling. You can do science and plan policy as usual. Others are prankish, random miracles, adversarial tweaks, tests with moved goalposts. The prankish versions are self-defeating for belief. If you adopt them, you lose reasons to accept them. The kind versions are compatible with trusting evidence. So, the sensible stance is conditional trust. Keep your methods unless you meet concrete anomalies that force revision, just as you would in base reality. Worries about morality blunt in the same way. If suffering inside a sim is just bits, it still matters to the minds that feel it. Pain reports and preferences do not cancel because the substrate is different. You don't need a metaphysical certificate to justify compassion. And politics, coordinating many minds with different needs, works with or without atoms. There's one healthy adjustment: prefer policy thinking over case-by-case impulse. Policies ask, what algorithm should a person like me run? If you adopt a policy that rewards blackmailers or liars in worlds with accurate predictors or overseers, you invite worse worlds, even when, in this moment, cheating looks locally profitable. Simulation talk just widens the audience for your policy. If the world watches, be the kind of agent you'd want multiplied. In the end, the simulation idea is a memento of humility, not a reason to freeze. Keep a small non-zero credence. Let it nudge you toward general-purpose virtues: robustness, transparency, kindness, curiosity. Live as if your choices echo, because in base reality they shape culture. And in a sim, they might be the point. Chapter 17, Parfit's Hitchhiker and the Price of Being Trustworthy. You are dying in the desert. A driver stops. They can save you, but they cannot make you pay later. They are, however, superb at reading people. They will help only if they believe you will voluntarily transfer the agreed amount tomorrow. In the moment of rescue, tomorrow's payment buys you nothing. You would already be safe. Yet refusing to pay means the kind of person you are, the one who won't keep costly promises, wouldn't have been saved in the first place. It disturbs because our local time-slice logic whispers, once on the couch with water in hand, don't pay. Paying now doesn't alter the past. But that logic ignores the selection step. The driver didn't help people, they helped types. If you're the type who would pay once rescued, you get rescued. If you're the type who would renege, you die in the dust. The rational thing is to be, and to remain, the kind of agent whose future actions make help predictable. One way to see this is to zoom out from acts to policies. An act-by-act thinker asks, given the state now, what action has best payoff? A policy thinker asks, which general policy, adopted in advance and stuck to, makes my life go best when others can predict me? The pro-payment policy wins. It buys rescue in all similar deserts. Keeping the policy when it pinches is the price of belonging to the class of people who attract cooperation, trust, and investment when enforcement is weak. Real life runs on this logic more than we admit. Honor system software licenses, tip jars after service, returning rental gear undamaged when inspection is perfunctory, paying a small contractor before the last nail is in, sending money for a ride a friend already gave. These only work because enough people act like policy thinkers. A community with many after-the-fact maximizers decays into enforcement and suspicion. Costs rise, offers shrink, and everyone loses opportunities. A skeptic might reply that reputation solves it. Pay today to protect tomorrow's deals. But Parfit's driver knows the deal is one shot. They rescue based on their prediction of your character, not your ability to be punished by Yelp. That's the point. Reputation is a tool. The deeper resource is credible character, a pattern steady enough that even unrepeatable situations attract aid. There is a quieter personal payoff. People who keep costly promises without external force buy an internal good, self-trust. If you believe your future self will predictably follow through, you can plan bolder, invest longer, and invite others into projects with less overhead. The price of paying tomorrow for nothing today is the ticket to a better class of games. If this still feels like philosophy cheating with words, try a thought switch. Imagine you could press a button now that permanently fixes you as a payer in such cases. Would you press it? Most say yes. Dying of principle in deserts is overrated. The action tomorrow is simply honoring what you would have wisely locked in if given the chance today. Pre-commitment devices, contracts, deposits, public promises are just external ways of pressing that button. So pay the driver, not because you owe the past, but because you prefer the world in which you are the person who pays. That world contains water. Chapter 18. Kafka's Toxin and the fragile thing called intention. You're offered $1 million at midnight if, right now, you form the intention to drink a harmless but painful toxin tomorrow afternoon. No one will watch tomorrow. They can only detect your intention tonight, and the payment arrives before the drink. When afternoon comes, the money is in your account, and there's no reason to suffer. You planned to intend, not to drink. Yet you can't seem to honestly form the intention when you know you'll abandon it later. The mind refuses to counterfeit itself to order. It disturbs because we imagine intention as a lever under full voluntary control. Just decide, but intention is a commitment shaped by reasons you expect to have when the time comes. Your tomorrow self will lack any reason to drink. Tonight's self knows that. The knowledge blocks the formation of a genuine intention. You can say the words and even hope to follow through, but you can't produce the inner posture on command when you anticipate that your later reasons will run the other way. There are ways around, and they illuminate what intention really is. If you could install a binding mechanism, sign a contract with a penalty larger than the pain, hire a friend to watch you, schedule a nurse to administer the toxin, then you could honestly intend now because you would have a reason tomorrow. Intention often leans on scaffolding, external structures that carry your plan through weak moments. We already live this way. We place the alarm across the room, text a colleague, we'll send the draft by noon, prepay for the gym. The mechanism supplies the missing future reason. Another route is to change what counts as a reason. If you treat keeping faith with your earlier self as a real stake, I do what I resolve to do because I care about being that kind of person, then the reason persists into tomorrow, and the intention can be sincere tonight. This is an empty virtue. People who integrate their plans across time get projects done, but you can't fake it. The point is to actually care about diachronic integrity, not to mouth it for money. The puzzle also separates intention from prediction and desire. You can want the million without wanting the pain. You can predict you won't drink. Neither equals intending to drink. Intention sits between wish and act. It is an organized plan with expected follow-through. The lesson for self-management is to respect that structure. Don't rely on bare intentions in places where tomorrow has no reason to cooperate. Build reasons in. What does it say about free will? Not that you lack it, but that agency has parts, commitments, reasons, scaffolds, identities. You are most free in practice when you design environments and identities that make good intentions easy to keep. The toxin case is extreme to show the joints, but the everyday analogs are gentle. Diets that work because the kitchen is stocked for them. Study plans that work because friends meet you at the library. Civility that works because you wrote the email and slept on it. So if a billionaire ever offers you the Toxin deal, either bind tomorrow so the intention can be real or refuse politely. $1 million for a fake intention is a trap. The better prize is learning to build intentions that survive the night. Chapter 19. Transparent Newcomb and the Power of Being Predictable. The classic Newcomb problem offers two boxes. Box A is clear and holds $1,000. Box B is opaque and holds either $1,000 or nothing. A near-perfect predictor has already filled box B. If they predicted you would take only B, 1 box, they put the million in. If they predicted you would take both, 2 boxes, they left B empty. When you face the boxes without seeing inside B, the old fight begins. Take 1 box and trust the predictor, or take both and dominate because the past is fixed. The transparent variant ups the tension. Now B is clear too. You can see whether the million is there. Suppose you look and the million is sitting right there in box B. Many people feel the dominance pull. Why leave $1,000 sitting in A? Taking both can't change the past, and you'll walk away with $1,001,000 instead of $1,000. Yet, the same reasoning would have led the predictor to leave B empty. People who are moved by the extra $1,000 in front of them are exactly the type who 2-box. If you're that type, the predictor's model would have been right, and the million wouldn't be there. Seeing the money is information about your type, evidence that you are the kind who 1-boxes even in the face of temptation. It disturbs because we're used to separating causal influence from evidential correlation. Your reaching for A now doesn't cause box B to have been left empty yesterday, but your disposition to reach for A in this very situation is entangled with the process that placed money in B. Treating the decision as a choice of policy, be the sort of agent who ignores the $1,000 when the million is visible, dominates across worlds with accurate predictors. Treating it as a one-off grab loses $1 million for $1,000 in the class of cases you care about. The lesson is not to worship predictors, but to value predictability in the right places. In bargaining, trust games, long-term partnerships, and institutional design, we keep running into versions of transparent Newcomb, small, immediate temptations versus a large pile that only exists for people who can safely ignore the temptation. Join a project that pays in 5 years, honor a warranty claim that no court could force you to honor, keep patient data private when selling them would be profitable and undetectable. The big pile is filled by the expectation that you won't snatch the $1,000. Skeptics ask, what if the predictor is only 70% accurate? The dominance of policies still shows up in the averages. 1-boxers win massively when the prediction is right and lose a trivial amount when it's wrong. 2-boxers win trivially when prediction is wrong and lose massively when it's right. As accuracy rises, 1-boxing at transparency stays the money policy. Think of it as cultivating a stable identity, a reputation you can rely on even when the quick win is glowing under glass. When institutions and people can forecast your moves in the tight spaces, they load the opaque box for you ahead of time. You don't need metaphysics to see the payoff. You just need the courage to leave $1,000 on the table when $1 million is watching.